Eta Carinae, one of the most massive stars in our Milky Way galaxy, unexpectedly increased in brightness in the 19th century. For 10 years, in the mid-1800s, it was the second brightest star in the sky. Now it's not even in the top 100. The increase in luminosity was so great that it earned the rare title of Great Eruption. A team of scientists, including Carnegie's Jose Prieto, now at Princeton University, and led by Armin Rest of the Space Telescope Science Institute, used images of Eta Carinae over 8 years to study light echoes of the Great Eruption. The new research demonstrated that this eruption was much different than previously thought. Eta Carinae is a luminous blue variable, or LBV, meaning it has periods of dimness followed by periods of brightness. The variations in brightness of an LBV are caused by increased instability and loss of mass. The Great Eruption was an extreme and unique event in which the star, which is more than 100 times the mass of the Sun, lost several times the mass of the Sun. Scientists have believed that this rare type of eruption was caused by a stellar wind. For the first time, they observed light from the eruption that bounced or echoed off interstellar dust tens of light years from the star. Those extra tens of light years mean that the light is reaching Earth now, rather than in the 1800s when people on Earth observed the light that traveled here directly. They then used the Magellan and DuPont telescopes at Carnegie's Las Campanas observatories in Chile to obtain spectra of the echoes of light. The spectra allow them to precisely separate the light into its constituents, much like a drop of rain naturally acts as a prism and separates sunlight into the colors of the rainbow. These observations give important information about the chemical composition, temperature, and velocity of the material ejected during the 19th century Great Eruption. Most surprisingly, their observations show that the Great Eruption is different from so-called supernova imposter events in nearby galaxies that are thought to be eruptions from LBVs. For example, the Great Eruption was significantly cooler than allowed by simple stellar wind models used to explain supernova imposters. This star's giant eruption has been considered a prototype for all supernova imposters in external galaxies, but this research indicates that it is actually a rather unique event. Thus, scientists still don't know what phenomenon caused Eta Carinae to erupt and lose such a quantity of mass without being destroyed. Further research is necessary to determine whether other proposed models could have triggered this activity instead. The work was published in the February 16, 2012 issue of Nature. The Carnegie Institution has had over 110 years of extraordinary discoveries. To continue this tradition, Carnegie scientists need your support. For more information about this and other cool science, visit our website at carnegiescience.edu. This is John Strom.